Hi everybody, it's Mr. Flanagan here again, and today we're going to learn all about the exciting world of what I call the upstairs-downstairs method of mass stoichiometry. Now I know a lot of chemistry teachers would be really upset because you need to learn how to cancel out units, and unit up here, unit down here, they cancel out, unit up here, unit down here, they cancel out. And that's a fine way to do stoichiometry. But I tried to come up with a more visual method, especially for those that might have trouble with math. I am going to assume that you know a fair amount of algebra, so I'm not going to spend a lot of time on that, but here it is. This is the key. This is what I've come up with over the years, if I can ever get it on camera. And it's going to look a little busy. There we go. Looks very busy. But here's what we're looking at here. There we go. We've got our equation, A and B giving C and D, not always 2 and 2, but sometimes. We've got our coefficients, that's what we use to balance our chemical reaction. Then we write in parentheses the molar mass of each chemical underneath, or whichever ones we're interested in. Down here, we're going to put the mass of the chemicals. We'll probably know one and we'll have to figure out the other. And then up here, we're going to end up with our moles of the various chemicals, because remember, a balanced chemical reaction really tells you moles. It doesn't tell you anything else. And here's the key. Whenever you're going from here to here, you're dividing only. So if I go from mass to moles, I divide by their molar mass to get up here. And when I'm going back down, I multiply only. So if I'm going from moles of B to grams of B, I multiply by the molar mass. So remember, go up, divide, go down, multiply. You might want to save this little picture, take a photo of it, print it out, whatever you want to do, but it's very, very helpful. The only thing missing is, well, how do I go from moles of A to moles of B, or moles of A to moles of C, or moles of D to moles of B? How do I do that before I go back up or go back down? Well, you know what? There is a way to do that. I call it, because it's all about ratios, the amazing mole ratio. The moles of A over the coefficient of A, you know, the number used to balance it, will always equal the moles of B over the coefficient of B. Always, 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 always. And you'll always have 3 of these, then you can solve for the other. You know, whether you're going to cross multiply or however you're going to do it. That's algebra that I assume you know, but this will always help. So hey, let's look at an example. I mean, how does this upstairs, downstairs method work? Well, here's a classic mass stoichiometry problem. Little Tommy wants to make 50 grams of water according to the reaction below. Please calculate the amount of oxygen in grams that he will need. And here's the reaction. Hydrogen gas plus oxygen gas makes water. Probably is a liquid. It's a kind of an explosion, but anyway, probably is a liquid. So how are we going to solve that? We have 50 grams of water, and we want to know how many grams of oxygen will we need. Okay, let's show you how the upstairs, downstairs works. Yes. Okay, so here is the reaction. So the first thing we need to do is we need to balance it. I think we're going to need 2 of these and 2 of these. See, that'll give us 4 H's, 2 O's, 2 O's, and that'll be our balanced reaction. So according to this method, the first thing we need to do is, hey, let's do that. We're only interested in the oxygen and the water. We know we're starting with 50 grams of water, or we want to make 50 grams of water, and we want to know how much oxygen we're going to need. So I don't really care about this. I just kind of needed it for balancing. So the first thing I do is, remember, in parentheses, I'm going to put the molar mass of each of these chemicals. You can look it up. 2 H's and O, 18 grams per mole. 2 O's, 32 grams per mole. So I did that. And where am I starting? Well, they tell me that I have 50, or I want to make 50.0 grams of H2O. So upstairs, got to go up to get to moles. What do I do when I go up? I divide. So 50, well, let's write that right here. 50 grams divided by 18 grams per mole. And that's going to give me 2.78 moles. So 2.78 moles. That's how many moles of water I'm starting off with. Well, next, I got to somehow get over here to moles of water. Because I'm going from here to here. See, because look, this is what I'm looking for. I'm looking for how many grams of water I'm going to get. Well, use that magic ratio method. 2.78, that's the moles, over 2, balancing, has to equal, we'll just call this moles of O2, over 1. Remember, there's really a 1 there, you don't really show, over 1. So how many moles of O2 do I have? Well, that divided by that, well, it's looking like if I do that on my calculator, 1.39 moles of O2. That's just 2.78 divided by 2. That gives me my moles of O2. It's over 1, so you could cross multiply if you want, but it's way too much work. So 1.39 moles of O2. All right, I need grams of O2. So what am I going to do? That's right, when you come back down, you multiply. So for moles to grams of O2, 1.39 moles. Moles of what? O2. Times molar mass, 32 grams per mole. 1.39 times 32 is 44.5 grams of O2. That's how much oxygen you would need. This method always works. Grams divided by molar mass, divide up, get your moles. Do a little ratio action, this over this equals this over this. It would also equal this over this. It doesn't matter where you start, that always works. Then coming back down to your new grams, in this case it was oxygen, you multiply when you're going down. This upstairs, downstairs method always works. Love any comments if you have them. This is Tommy Flanagan with a little bit of a longer video, but it's kind of a tricky thing, mass to mass stoichiometry, saying goodbye. Hope you enjoyed it.